Hello, everyone. Thank you for joining us. I'm Kengo from NTT Data. In this talk, my colleague Masatake and I will show you a project called Apache Bigtop, which is a community-driven Hadoop distribution. And just for your information, there is another Bigtop talk tomorrow in which Yuki from ARM and Luca from Wikimedia will present a new feature of Bigtop and a real case of migration to Bigtop. I strongly recommend you to see it too if you are interested in Bigtop. Let me introduce ourselves shortly. We are open source developers and data infrastructure engineers working at NTT Data. We are also committers and PMC members of some ASF projects, including Apache Bigtop. In this talk, first, I'll show you an overview of Apache Bigtop and its usages from users' point of view. Then Masatake shows advanced topics such as upgrading Bigtop components and add new component to Bigtop software stack from the developer's viewpoint. First, I'd like to show you what is Apache Bigtop with its history. According to the official website, Bigtop is an Apache Software Foundation project for comprehensive packaging, testing, and configuration of the leading open source big data components. But this explanation may sound a bit abstract. So if I put it in other words, Bigtop is a Hadoop distribution developed by open source community, and it makes it easier to build and test Hadoop-centric data platform. Here is a history of Apache Bigtop. Bigtop was started in 2011 and have been grown by many contributors. The new versions have been released steadily, around once a year. As this figure describes, we have added new software as Bigtop components and upgraded their versions to more recent ones. The next version number of Bigtop is 3.0. This is because our component stack is based on Hadoop 3 from this version. The first Hadoop 3 was released in 2017, but we couldn't catch up with it for a few years. So it's a great leap for us. With this change, we can leverage new features introduced in Hadoop 3, such as erasure coding, and keep up with forthcoming upgrades. On the other hand, it will introduce some incompatibilities with Hadoop 2, and we had to drop some components which are incompatible with Hadoop 3. So we decided to adopt version 3 for the next Bigtop release in accordance with Hadoop to tell those improvements and incompatibilities to users. In this slide, only a part of the component is shown. So I'll show you the complete list in the next slide. Here is the full list of Bigtop 3 components. In addition to Hadoop, it includes a wide range of big data software, such as key-value store, SQL engine, streaming processing engine, streaming storage, log collector, notebook, and so on. Unfortunately, some components will be dropped due to incompatibility with Hadoop 3 or project inactivity. As of recording this talk, Bigtop 3 is not released yet, but it will in the not-so-far future. This is a screenshot of our CI result. This matrix represents we already succeeded in building all components for all Linux distributions and CPU architectures we support, except for a few cases shown by red circle. We also still have a few smoke test failures and a few issues prepped, but I expect those problems will be resolved in a few months. I've shown Apache Bigtop's overview so far. In the next section, I'm going to explain Bigtop's main features and how to use them from user's point of view. Unfortunately, our documents are not so user-friendly for now, so I'd like to remove a barrier for new users through this explanation. When someone wants to build a data platform, what kind of tasks are needed? I think typical steps are as follows. First, users select software that meet their requirements. Someone may need a distributed file system and an execution engine on it. Or another one may need a distributed key value store and its SQL interface. Once software is decided, users have to investigate compatibility between their versions and their prerequisites, such as dependent libraries. Then they install the selected software to servers and configure settings on all of them. This can be too heavy to do manually if the number of servers is large. Finally, they will check if the platform works as expected before using it. And sometimes they want to rehearse those processes or virtual environment before doing them on the production environment. Bigtop makes those tasks easier by providing these 4 features. Let's take a look into them. The first feature of Bigtop is providing components as packages. Bigtop provides its components as packages in the Debian and RPM format. So the compatibility between components is already assured, and required packages are also installed automatically. Users can install components with a single command using a package manager, such as yum or apt. As these tables show, Bigtop packages are provided for major Linux distributions and CPU architectures. So if you are working on them, installing components are very easy stuff. Bigtop is publishing its repository on the internet, so you can use it freely. Repository definitions, such as .repo or .list files, are available from ASF download site. I'll show you an example usage in the next slide. Installing repository definition and the install components from that repository are easily done by 3 steps. Here's an example of CentOS and Fedora. First, download and install repository definition from the ASF site. This URL is the same as introduced in the previous slide. Change Bigtop version and Linux distribution in the download URL in accordance with your environment. Next, import GPG key for ensuring downloaded files are correct. This GPG key is also available from the same ASF site. Finally, you can run the package manager to install component packages. In the case of Debian and Ubuntu, required steps are the same. Install repository definition, import GPG key, and run the package manager. The second feature of Bigtop is deployment automation. Though Bigtop provides components as packages, it is time and labor consuming to run install command on each server manually. In addition, users usually have to configure component settings after installation. Thus, some means to automate those processes is required. For this purpose, Bigtop provides Puppet manifest for each component. Puppet is a long-established and proven configuration management tool. Puppet users can define server state as manifest using rich DSL, and Puppet does all required works to satisfy that manifest. Also, users can configure component settings through Hiera, which is a key-value lookup system for Puppet. Bigtop Puppet manifests are available as a separated table from component packages already introduced. Users can download it from the download link shown here. Applying Puppet manifest is a bit more complicated than installing packages. First, download and extract Bigtop release table. Next, install Puppet using a script included in the table. Then, edit Hiera YAML file to define install settings. Users have to set a value for these 3 parameters shown here, at least. Of course, users can configure for detailed settings, so check the YAML files under bigtop-deploy/puppet/hieradata and override them if needed. Finally, copy Hiera files into the designated directory and run the Puppet apply command. If the deployment succeeds, the Puppet apply command will return status code 0, and the provision services should be started, as this example. This is only an example of executing HDFS and YARN commands on the deployed cluster. The third feature of Bigtop is smoke test. Now we understand we can build a cluster almost automatically using Bigtop's packages and Puppet manifests. But that's not sufficient. Once we deploy the Hadoop cluster, we usually like to make sure it was successfully deployed without problem. Bigtop smoke test is for this purpose. It runs the basic functionalities of components so that we can ensure they are all properly deployed. To run the smoke test, follow these steps shown here. First, download and expand the Bigtop release table. It's the same file as the one we used in the cluster deployment. The second step is a bit tricky. It removes an obsolete test duplicated in Bigtop version 3. But that test depends on a third-party library, which is no longer published in the original repository. So the following grade_w command will fail without this step. The third step is setting environment variables required to the test. Each smoke test requires different variables. For example, Spark needs Spark_home and Kafka needs Kafka_home. So check the build.grade file for each component to know what variable is needed for the test. The last step is running a smoke test. This command runs a smoke test for YARN. You can change the YARN part in this command to run other tests. After running a smoke test, you will see messages and result like this. If you want to know the details of the result, you can access the shown path to see a report in HTML format. Here's an HTML report of the smoke test. You can drill down to each test result by clicking the links. The last feature of Bigtop is provisioning. By using this, you can try the steps explained so far on Docker containers. By using the Docker provisioner provided by Bigtop, users can execute the steps explained so far on Docker containers. That is, users can deploy a cluster with Bigtop packages and Puppet manifests onto containers and run smoke tests on them. It is very useful for POC work, early evaluation, or rehearsal of building or migrating a cluster. Developers can even build Bigtop packages themselves in a Docker container by using this feature. Masatake will elaborate this later. As prerequisites, users have to install Docker and Docker Compose and do required settings in advance to use this feature. And to be precise, Bigtop also provides Vagrant Provisioner, which uses virtual machines instead of Docker containers. But its functionality is quite limited and rarely used, so I don't mention about it anymore. To use the Docker Provisioner, download and extract the Bigtop release turbo, then run gradlew docker-provisioner command with some options. In this example, we provisions a cluster on 3 CentOS 7 containers and install HDFS and YARN provided by Bigtop 1.5 into it. After the command succeeded, you can manage the containers using normal Docker commands. In this example, the deployed services are listed, but you can execute any command via the Docker exec command, of course. Docker Provisioner has many options, so it may be confusing at first. You can list all options by running the gradlew tasks command. This is the end of my part. In the next part, Masatake will show you more advanced topics, such as developing Bigtop itself.
From here, I'm going to talk about Bigtop and its background in detail from developer's viewpoint. I would like to talk about platform supported by Bigtop first. Bigtop is assuming Linux. While Bigtop supports multiple Linux distributions, it does not cover other OSs such as Windows or macOS. The reason, in my understanding, is Hadoop effectively supports Linux only as a server platform. Majority of Hadoop-related projects are written in Java. The Java code is basically portable. CLIs written in shell scripts are assuming Linux. Native library for extra features and performance enhancement depends on Linux features. While there was effort for supporting Windows as a server platform, related code are no longer maintained in Hadoop. I think majority of Hadoop developers are using Ubuntu on Intel architecture. Portability issues on other platforms tend to be missed. Hadoop and many related products are written in Java. Bigtop3 uses OpenJDK 8 provided by Linux distributions. While you can use Java 11 as runtime of upstream Hadoop, migration to Java 11 is still in work in progress in Hadoop community. Some products uses Python. As you know, Python 2 and Python 3 are incompatible. Python 2 and Python 3 coexist in recent Linux distributions. We need patching Chevron lines for fixing ambiguity. packages built by Bigtop uses System 5 init scripts now. Migration to unit file of System D is not yet done, while we can do it now. We met some issues on testing packages in Docker container. Generally, it is not recommended to use System D in container. We need to address the issues for testing services of the packages. Bigtop is addressing compatibility issues between products. I would like to introduce some topics for understanding motivation here. In Hadoop ecosystem, compatibility between products is not stable. Because each product is developed by independent group of developers, changes in Hadoop tend to break build of downstream products like HBase or Hive. In Java code, public method public class is accessible from outside. Changing it may be incompatible change. There are lots of public classes and methods for using them between submodules, while it is intended to be product private. Hadoop uses annotation to show the intended visibility, but it is sometimes violated due to historical reason. Hadoop and related products uses Maven as build system. The dependency graph between Hadoop products tend to be complex. Arbitrary combination of versions of products usually does not work due to version conflict of popular utilities. There is ongoing effort for mitigating this by shading. It is not complete yet. Bigtop still need to adjust versions of dependencies on packaging. While main API is written in Java, CLIs are provided for users' convenience. Typically, the CLI is shell or Python scripts invoking Java APIs. Sometimes product A passes standard output of CLI with product B. Changing output messages of CLI may turn out to be incompatible change in such a case. I'm going to introduce basic Bigtop resources here. The Bigtop source code is hosted in GitHub. We are using Jira for issue tracking. I think this is same as most of SF projects. Bigtop is leveraging Gradle. You can grasp the features by seeing lists of Gradle tasks. Bill of materials named as bigtop.bon is a place for defining the packaging. It is written in format used by Groovy's module. You can change the product versions or download URLs of source tables by modifying the Bigtop bon. You can use Bigtop toolchain for setting up packaging environment. A Bigtop toolchain consists install script of Puppet and Puppet manifests. Tools needed for packaging such as JDK, Maven, GCC are installed by Puppet. Hadoop and other products requires recent version of Maven, which are not provided as a standard package of OS distribution. A Bigtop toolchain uses binary or source tables in such a case. Some products require old protocol buffers which does not yet support ARM or Power architecture. Bigtop toolchain applies backporting patch, adding architecture support to address this. Recent versions of Hadoop, HBase, and some other products leverage Protobuf Maven plugin. The plugin automatically downloads prot.c binary and uses it to process .proto files. Developers do not need to install protocol buffers by their own. Since old prot.c binaries for ARM and Power platforms are not provided by Maven repositories, Bigtop locally installs artifacts based on patched protocol buffers to local repository. We are going to talk about packaging stuff. A Bigtop package tree contains files needed for packaging. A Bigtop supports both RPM and deb packages. You can build packages by invoking Gradle task named with product name suffixed by -pkg. For example, you can get Hadoop RPMS for CentOS by running Hadoop-pkg task on CentOS 8. You can get HBase dev files for Ubuntu Bionic by running hbase-pkg task on Ubuntu Bionic. You can build multiple products in single command line. Packaging stuffs are contained in the directory tree shown here. Common logic for building and installing are written in common scripts. Distribution-specific sources, such as .spec or rule files, uses the common logic. Since we need file listings in different way for RPM and deb, we usually need to fix 3 files to update the file locations. Files named as patch.df are applied on the fly on packaging. There are various reasons. Sometimes issues arise on specific OS distributions or platforms. Sometimes we need to backport or revert fixes to address compatibility issues. If we need to write a patch on our own, we contribute the fix to each project as far as possible. If packaging task is successful, output package files are placed in the directory named as output. You can create YAM or apt repository in place for local testing. Gradle's repo task is used for this. You can do packaging in Docker container by invoking product name -pkg-indi task. It means in Docker container task. You can build and test packages for all supported OS distributions on single hosting environment. Which Docker image is used can be specified by arguments like this. Repo task also has -indi variant too. I'm going to talk about provisioning stuff next. Docker Provisioner is a tool for setting up Hadoop cluster on localhost for testing. You'll need Docker Compose in addition to Docker for this. Example command lines shown in this slide create 3 CentOS 8 containers and set up HDFs and YARN services. You can understand the Docker Provisioner well by seeing generated configuration files. From Docker compose.yaml, you can see that source tree of Bigtop is mounted as root Bigtop whole in the container. From site.yaml, you can see the configuration passed to Puppet manifests for setting up products in the container. Puppet manifests for setting up Hadoop cluster is contained under Bigtop deploy directory. Docker Provisioner inject configurations via Hiera YAML file. While Bigtop developers use this for internal testing, it also can be used as template for real deployment of end users. Here we can talk about testing. Smoke tests is basic integration test of packages. The test cases are written in Groovy. It typically invokes CLI and tests that expected output is returned. I think the coverage varies between packages and should be improved overall. Bigtop developers usually run smoke tests in container launched by Docker Provisioner. You'll need to add -- smoke test option for this. The option takes comma-separated product names as an argument. Let me summarize this talk. Apache Bigtop provides working combination of data processing products centered around Hadoop as packages. Bigtop 3 is the first release providing stack based on Hadoop 3 and Spark 3. We are planning to migrate to Hadoop 3.3 well later in the next release of Bigtop 3.0. Thanks for your listening.